Most of the water for the residents of the Salt Lake Valley originates as winter snowfall in the nearby mountains. In the spring and summer, this water melts and is transported downward by mountain streams, and then ends up in our homes. Wastewater is then treated and put back in the Jordan River, where it makes its way down to the Great Salt Lake.
We do not have a lot of water storage or reservoir storage built into that system.
This problem will be exacerbated as our climate changes in the future.
So the temperature analysis that we've looked at, we see warming anywhere between 2 and possibly even 4 degrees Celsius by the end of the century. And those warmer conditions would be conducive to more of our precipitation coming as rain, a little bit less as snow, and then once the snow's on the ground, the warmer temperatures will be consistent with it melting earlier and faster.
The one result that you might not expect is we also decrease that volume. As you decrease the snow cover season, you lengthen the growing season in the watersheds and you lose more water to evapotranspiration.
So runoff starts around June every year, and that runoff is the supply of water. And as the streams start to get lower during the hotter parts of the year, around August we start bringing on some other sources from stored water in another part of our watershed. And the stored water is really our insurance for a drought. If the snowmelt that feeds those streams starts happening earlier, then we start seeing this gap emerge between the peak of the supply and the peak of the demand. So our demand in the Salt Lake Valley starts peaking in around August, and right now we have a little bit of a gap to make up through some other stored water. But we might see that gap shift, in which case we'll have to figure out how to make up that demand.
So in the future, we expect demand to go up in the summer, but for the available water to decrease and come earlier in the spring.
You know, obviously, as the temperature increases, we are going to see a greater need for other types of water storage, potentially. Or we may look at the demand side and see a greater need for additional types of water conservation methods. So one strategy might be that we take some of that water that comes off the mountain earlier in the year that there really isn't a high demand for because people aren't starting to irrigate outdoors yet, and we take that and we inject it into a groundwater aquifer and store it in the aquifer.
Because we'll have less snow and less runoff in the future, we need to find ways to make up our gap between supply and demand. We cannot make up this gap with storage from new dams, so we may have to look towards summer conservation methods, such as limits on watering for irrigation and possible water reuse.
I'm not positive that water conservation will be on its own able to solve that gap over time.
I have not yet met a water manager who is not very concerned about having a reliable water supply into the future, and this is something that we really have to consider and we have to plan for.